So, a very good afternoon to you all. So, welcome to the session. So, today we will start with a new data model called vector data. So, as explained in the first lecture, as all of you know that what is geospatial data. Geospatial data is data about the about different features on the on or near the surface of Earth, right? So that all, like, how do we represent all those features which are on the surface of Earth or maybe near the surface of Earth? That what we call geospatial data. Right. So then there were two data models for representing geospatial data. One was a raster data that we have discussed in detail. So another kind of data model for representing geospatial data, that is called a vector model. So vector model. So in a raster model, the data on the surface of Earth was being represented as a grid of cells, right, or a matrix of cells, where every cell or pixel was representing some value. Now we will talk about another kind of representation that is called vector data, right? So like here you can see this is the map of Delhi metro or some other metro, right? So vector data represents object on the Earth's surface using their longitude and latitude as well as the combination of the pair of coordinates, right? So vector data is a vector model is then another model where the features on the earth feature on the surface of earth are represented using their latitude and longitudes, right? Or maybe a set of the combinations of these latitude and longitude. So there are, so all different features on the surface of earth can be represented, say, as maybe as a point data, like all where as vector, all features on the earth surface can be represented, maybe say, as point data. Point data is represented as a pair of coordinates called longitude and latitude that represents the location of that point on the earth surface, right? Or some features on the surface of earth may be represented as a point data, right? So the point will be represented as a pair of coordinates called longitude and latitude. For example, locations of some drop boxes, or say locations of some specific landmarks on the surface of earth will be represent can be represented as points. Or even if you say, if you are seeing the at very coarse resolution, then we can say even some cities also we can represent, say, as points, right? So a point will be represented as a pair of coordinates called its longitude and latitude. So the different types of location, like a location of some drop box or some post box, or location of some landmark, some building, or even cities can be represented as point depending on which scale we are representing the data. So a point will be represented as two pair of coordinates, longitude and latitude. So then the second kind of data structure or say data type used for representing features on the Earth surface is called line. So line is a series of points. So a series of points that represent a line on Earth's surface, right? There are some features on the surface of Earth that cannot be represented just using points. So they may be represented as a series of points, right? So that represent a line. So that will be a set of these different points, right? Suppose if you want to represent centers of roads or road network, or say road river, so that cannot be just represented as a point, so they can be represented as lines. Lines means a series of points, series of multiple points connected together, right? Like here we can see that these different points connected together is called a line. Like it has multiple these vertices, and these vertices are connected using this. Then the line can be a curved line like this, or can be a straight line. Then another way of representing feature is called polygons. Polygon is a series of points that define the outer edge of a region. For example, outlines of a city, country, or continents can be represented using polygons, right? So polygon will be a set of points, and it will be a closed point. So whatever starting point is there, the same is going to be ending point, right? So a series of points that define the outer edge of a region is called a polygon. Like here you can see that these are the these polygons might some might represent the outline of a city, country, or maybe even say a building, right? So this is a typical example of suppose this, if you want to represent some features from the surface on like this, suppose this is a river, so this river can be represented as a line feature, right? So river and roads can be represented, or this and this road can be represented on the map as a line. Then similar with this house, we can represent as a polygon containing its outside boundary, and some trees from the this landscape can be represented as say points. Like this, depending on which feature we are representing, we can choose, or which, depending on the type of feature and the scale at which we are going to represent those features on a map, you can choose appropriate data structure, maybe line, point, or polygon to represent those features on the surface of on a map. Sorry. So right, for reading and writing vector data, we will not be using GDAL. We will be using another versatile library called GeoPandas. So I'll be using GeoPandas. For installing GeoPandas, you need to install, like on your environment, just conda install -c conda force and GeoPandas. So it will install GeoPandas to your local environment. Actually, I have created a new environment with name GOP. If I actually, some of the things were not working on the previous one, so I will go to the my current environment. So before that, I will introduce to another library called Pandas. So GeoPandas is just an special extension of Pandas. So GeoPandas is, so here I will just give you an introduction to the data frame and series data structures of the Pandas library. Then we'll see how do we access and manipulate within the data frame and data series. Then we will see how do we import a CSV file into Pandas data frame, and then we'll talk about what is data frame and what is series. And actually, GeoPandas is just a special extension of this Pandas library where we can store geometries. As we said that vector data is represented as these geometries, line, point, or polygon. So GeoPandas is a special extension of Pandas. So Pandas is an open source BSD licensed library that provides high performance, easy to use data structures and data analysis tool for Python programming language. So Panda is basically a column oriented data analysis Python library. It is great tool for handling and analyzing tabular data. So there are the primary data structure in Pandas are implemented as two things. One is called series. So series, like you can say, it is a single column. A single column in entire table is called a series in Pandas parallels. So series is single column, and data frame is a collection of these columns. Like if you see a spreadsheet, every column of that spreadsheet is called a series, and the entire table together is called a data frame. Right, so data frame, which you can imagine as something, a relational data table with the rows and columns, and out of that entire table, a single column is called a series. So once Pandas is installed or GeoPandas is installed, then we can import these libraries. So I'll just copy the path. So my all data is available in this directory. So first we'll see how do we create Pandas series and Pandas data frame. So this way we can import Pandas library to our Python environment. So import Pandas as PD. This is the general convention used altogether, and OS Shapely is a library that we will be talking about while using geometries. So how do we create a column? As we said that Pandas series is just a column, right? So how do we create a series? So PD dot. So if you call PD dot. So PD dot series, and what all values are there in that column, that can be separated by comma. Like to the series, we can pass a list of elements, right? So suppose here we want to create the name of cities in Uttarakhand. So then we can say PD dot series, and in the we can pass to this function a list of city names or any values which you want to store in that column, right? So now you can see that a column got created. Now similarly, suppose now combining these multiple columns together, we can create a data frame. So data frame object can be created by passing a dictionary mapping string column names to the respective series. Right now here we are creating first two columns like city names and there may be their population. Then while creating a pandas data frame, we can call the function pd.dataframe and pass it a dictionary containing the name of those columns and which series to link to that column, right? So like here, we have passed a dictionary containing this key and value pair where key is the name, will be the name of the column and value of that column will be the series associated with that column. Like city names, in city names, we are passing the city name series and in population, we are passing the population. Right, so like this we can create, so now you can see that the entire table got created. So this is a pandas data frame. So by just calling pd.dataframe, we can create a data frame. Then similarly, suppose if you used to read a CSV file using pandas, so like I have a stations.csv file available in my folder, then we can call it using pd.read_csv. So with the help of pd.read_csv, we can read a CSV file. Now if you see, so this is our data file, like it contains these columns: station ID, station name, name of station, then the location of that station. So actually this file will be using tomorrow, how do we convert this lat long data from lat long to a shape file or any vector format, right? So this way this is a vector file containing the location of different air quality monitoring stations across Uttarakhand. Right, so this is like this way we can read a CSV file using pandas. So then suppose if you wish to see some details about this data frame, then there is a data frame there is a function called describe. So describe gives you information about all numerical columns available in your data. Anyway, there are only two numerical columns, latitude and longitude. So then it gives the basic statistics of, there are more than one numerical column inside this your data set. Then it gives the basic statistic like count, mean, standard deviation, minimum, 25th percentile, 50th percentile, min, max, and whatever. Like so, with this you can get the basic statistics about all numerical data available in your data frame. Then suppose if you want, instead of seeing the entire table, suppose if you want to see some initial top 10 rows or top 5 rows from your table, then you can go your data frame dot head. So it first prints 5 top rows from initial rows from your column. Similarly, suppose if you wish to see the last 5 rows, then you can call df.tail. So then if you wish to see like 7 or 8 initial, then you can pass it an argument as number, like I want to see the 7 rows. So it will fetch you the first 7 rows from your table or data frame. Right, then suppose if you wish to access some specific column, then you can just pass your pandas your data frame, then inside square brackets you can pass your column name, then it just fetches those column names. Then suppose if you want the second entry from the column name, then you can pass second index as well, right? Because this is a tabular structure, station ID and second entry, so that it will fetch you the this. Then you can do the slicing as well, like we have done in the numpy arrays. So like station ID 4th to 8th, 4th to 7th, actually 8th will be excluded. Suppose if you want to extract 4th to 7th column 1 from this way you can go. Then suppose if you wish to specify, like you want to fetch the record that contains station name is equal to Nagthat or some name, right? So then you can specify df your data frame, then inside square brackets df for the you are looking for the value in which column, like df dot station is equal to Nagthat. Suppose if I wish to fetch, so then we can, but then you can specify multiple columns, multiple conditions also, and so on. Like this, you can keep on writing any complex expression for searching the data inside your data frame. Then you can apply some basic, you can manipulate every column. Like suppose if you wish to apply some mathematical operations on any column, right? So like suppose if you the latitude, if you want to convert it to minutes, so then suppose if you wish to multiply that column number by 60, so then you can create like a new column df lat in min equal to df latitude multiply by 60, And if you see, a new column must have been created here. So now you can see a new column with latitude in minutes got created. It's like this, you can do any mathematical operation by combining one or more number of columns like this quite easily. So indexes, both series and data frame objects also define an index property, right? So till now we have seen that we have given just name to every column. Suppose if you wish to give some textual name or some incremental name to every row in your data frame as well. So that is the index. Index is the label attached to every row in our data frame, right? By default, at construction, pandas assigns index values that reflect the ordering of the source data. So by default, it will be creating an index with starting with 0, 1, 2, 3, 4, and so on. Then if you wish to change the label of the row of your data frame, that also can be done. Like suppose if I'm fetching the default index, df station id dot index, so it says its range start from 0 to number 1 to 52. It has started the monotonically increasing series. Then you can by reindex, you can change the indexes of your order. Then you can assign even the textual label to your rows as well. Then by reindex, you can just reorder your rows, right? So df station id dot reindex 201. Suppose if you want to change the order of rows from 01 to 2, you want to swap them to 210, then you can by reindexing you can swap those, right? So like this, you can see that the second row has come, third row also actually has become the row 0. Then like this you can reindex. Then suppose if you want to sort the columns, then df dot sort values, then by you can specify the column number on which you want to sort your data frames. Like this is the basic introduction to pandas. So then now we will talk about the library which we are going to use for today is called GeoPandas. So in this, we will try to gain an introduction to the geo data frame. So that is the spatial extension of pandas data frame, and geo series, you can say the data structure of GeoPandas library. So in pandas, they were data frame and series. So in the GeoPandas, they are geo data frame and geo series. So now then we will see how do we access and manipulate data within a geo data frame and a geo series, as we have done in pandas data frame and series. Then we will see how do we read vector data, different vector data, as raster data is available in multiple formats. Similar to this, vector data also is available in multiple formats. So we will try to read today, in today's session we will just try to read those different like whatever different formats available. So we will just try to read some of those formats using GeoPandas. Then in the subsequent lecture we will see how do we manipulate or create maps from that data and process that data. And finally we will see, suppose if you have your vector data, how do we write it to a vector format. So GeoPandas also is an open source project to make working with geospatial data in Python easier. So Pandas objective was to work on tabular data, working with tabular data to make it easy to work with tabular data. GeoPandas is to make working with geospatial data or especially vector data in Python easy. GeoPandas extends the data types used by pandas to allow spatial operations on geometric types. So as I said that because pandas doesn't allow operations on geometrical operations, right? So GeoPandas is an extension of pandas for storing and manipulating different kinds of geometries that, as we discussed, maybe line, point, and polygon. So the operations on these points, line, and polygons are not available in pandas, so those are available in GeoPandas. So the primary data structure in GeoPandas are implemented in two classes as they were in pandas. One is GeoSeries. So GeoSeries is essentially a vector where each entry in the vector is a shape is a set of shapes corresponding to one observation, right? So GeoSeries is like a column where every row in that column is one of the set of shapes corresponding to one observation. So so like it might represent a single point or a line or a polygon. So every row of GeoSeries will represent one observation, right? It might represent one single point. So suppose if you are in our vector data file, there are 10 different points, like this is the point data, then every point will be stored in a single row, right? So geoseries is as it reads is essentially a vector where each entry in the vector is a set of shape corresponding to one observation, right? So every row of the geoseries will represent a single observation. So geopandas has basically three classes of geometric objects. So every geopandas like this geoseries, every observation of geoseries can be of these types. It can be a point or multi-point, can be line or multi-line or polygon or multi-polygon, right? So every entry in that geoseries column will be maybe either a point, line or polygon. It cannot be both together. The geodata frame is a tabular data structure that contains a geoseries, right? So as series was a collection of data frame was a collection of multiple series. So geodata frame is a tabular data structure that contains at least a geoseries. So geoseries contains all geometric data. It doesn't contain any normal numeric data. The most important property of geodata frame is that it always has at least one geoseries column that holds a spatial status. This is called the data geodata frames geometry. Right now, you can say that this is a series. So these are all are series that might contain some normal data. It may be a numeric data or a textual data. And geoseries is a special kind of column that contains geometries. Right. So every row in the geoseries will contain a geometry. It might be a point, line, or polygon. So geodata frame is a tabular data structure that contains at least one geoseries. So plus it can contain more than one geoseries, but out of those all geoseries, one geoseries will be designated as the geometry of that data frame. Right. Now let us see all this in action. So now see how do we read. Actually, today we will just focus on the reading vector data. So vector data format also actually vector as we said that like raster data, vector data also is available in different formats. So one of the most popular format is ESRI shapefile. So this is the simple non-topological format for storing geometrical location and attribute information of geographic features. So it does not store the information about topology of the features like their ordering. Topology is all about ordering, like which comes first, which comes second. So it doesn't. It is a non topological format for storing all geometrical locations. So the shape file can contain geometric data as well as some attribute data. Like suppose if you see a point, so point will have both spatial and non-spatial attribute. Spatial attribute means its location, like its latitude and longitude, and non-spatial attribute may be like the name of the that point and many other attributes associated to that. So the save file format defines the geometry and attributes of geographically referenced features in three or more file with specific extensions. So in the shape file format, there will not be a single file, there will be more than one file. So different files storing different kind of information. Right. So the once you see a shape file, though the file with .shp extension. So a shape file format is a collection of different files. You can say at least there will be at least these three files: .shp, shx, and dbf. So the .shp file, this is the main file that stores the feature geometry. So it is required. Like without if this file is missing from your collection of the shape files, then any software or even pandas will not be able to read that file. Then so the .shp file contains that all feature geometries, and the .shx files, this file, this is the index file that stores the index of feature geometry. So this is also required file. So the SHX file requires the indexes, that's indexes of that feature geometry. And .dbf file, this is the DBase table that stores the attribute information of the features. So these, at least these three files are essential for reading any shape file format, right? So SHP that stores the geometries, SHX that stores the indexes of these feature geometries, and DVF stores all non-spatial attributes. Then these are other optional file like .sbn and sbx. So this file stores the spatial index of the features and projection, and that .prj file that stores the coordinate system information, right? So for effectively working with a shapefile, we need at least these all files together. So these three are compulsory, and without these files, we may not be able to project these features on the map, but we may be able to work it. But suppose if you wish to project them and on the map as well, then these files also are required, right? So then there is another popular format for storing vector data is GeoJSON. GeoJSON is a format for encoding a variety of geographic data structures, right? So as we said, line, point, and polygon, a GeoJSON object may represent a region of space or say a geometry. So GeoJSON is a format for encoding a variety of geographic data structures, right? So GeoJSON is an extension of JSON where which stores data in a key value format. So GeoJSON object may represent a region of space, a spatially bounded entity, or a list of feature, right? So a GeoJSON can represent anything, right? It can represent a point, line, or polygon as well, right? So these are called geometries. Or it can represent, so a geometry is just a region of space, like you can say it is just a geometry. Then a spatial bounded entity is a feature. So when we are attaching some non-spatial attribute also to that geometry, that in the GeoJSON parlance we call that a feature. And a list of features is called a feature collection, right? At the bottom there is geometry, so that will be just telling the geometry of the object, whether it's like suppose if it is a point, then it will be telling its latitude and longitude. If it is a line, then maybe the set of all vertices of that line, right? So that is a geometry. Then when we attach some attributes to that, that will is called a feature. So spatially bounded entity, so entire entity that contains information about, so in feature, so when we are attaching other non-attribute information like apart from the geometry, that we will be calling feature. And when there are such multiple features in a single collection, that is called a feature collection, right? So GeoJSON supports the following geometry types: point, line, string, polygon, multi-point, multi-line, string, and so on. So features in a GeoJSON contain geometry object and then additional parameters. And feature collection, as you say, is a list of features. Like, so for representing maybe some features on the Earth surface, we may be generally using a feature collection. Like all these features are there because generally there will not be a single feature, which is just single point. Then only it can be. Otherwise, generally it will be a feature collection. Right. So this is a typical example how the data is stored in GeoJSON format, right? So it might first be these are different keys in that. So first is type is a feature. So it is saying that the first information or element what is stored in our GeoJSON file is a feature. So that is geometry plus attributes. Then the geometry of the uh, uh, feature will be represented with a geometry key. So geometry and then colon, then this is a type, whether this is what is the type of the geometry, it is a point, then what are the coordinates of this, like this. Similarly it can be line or a polygon. Then other properties, like these are non-spatial attributes, like what is the name may be Dehradun, and maybe some additional attribute like what is the temperature on that city or whatever, like this. A feature will be represented like similar way when it can be a feature collection or it can be just a geometry as well. So then there are other format for storing vector data like geography markup language or GML, keyhole markup language, KML, MongoDB, Microsoft SQL Server, Spatial Database, OGC, WFS, Web Feature Services, and all. So these are different formats available for storing vector data or geo database. Some of these in some of these formats we can just store single layer, and some of these formats support multi-layer writing, multi-layer storing as well. Now let us see how do we read. So and already we have installed GeoPandas. So for importing GeoPandas, so this is what generally we use the extension import GeoPandas as GPT. NumPy anyways, NumPy Matplotlib is for plotting. Actually, GeoPandas also use a very high level interface of Matplotlib. You need not call specifically Matplotlib for plotting GeoPandas series. So Matplotlib itself has internally we'll be calling matplotlib. GeoPandas itself will be internally calling matplotlib, so it provides high level interface for accessing matplotlib features. Right, so then from GeoPandas we are importing GeoSeries, then GeoDataFrame also we can import. So if you wish to know what version of GeoPandas is installed in your system, then you can call gpd dot underscore underscore version underscore underscore. So this is what is called a magic attribute actually. So now let us try to see read a state boundaries. So I have a shape file containing the boundaries of all states across India. So actually these state boundaries are I have downloaded from the Survey of India website. So like here you can say that state boundaries. So like here if you see state boundaries, there are these all files which I discussed about are available in this, like state boundaries dot shp, state boundary.shp, SBX, SBN, PRJ, and DVF. And there can be some additional files also that are not necessary but are required for effective operation. Right. So these are all files. While reading the file using GeoPandas, we need to just specify the name of shape file. Any other files are not required. So it will look for all these associated file ancillary files also in the same directory. If any of them is missing, then GeoPandas may not be able to read that entire information from that save file. Right. So I have created a variable called vector file. In this, just I have stored the name of that file. And for reading the file, the function we need to call our GeoPandas dot read underscore file and pass it the name of just the shape file which you wish to read. Right. Now if I call and if I store that in a variable called India, right. Now if I see the type of India, what is the type of India? It should be a geodata frame. Right. Now it means we could successfully read the vector file. Right. As we said that a geodata frame will have a column designated at the geometry of that column. Suppose if you wish to know in this India geodata frame which column has the designation of geometry, right? So then we can call the function like on our geodata frame dot geometry dot name. So it says that there is a column with the name geometry is available with the name geometry, that is designated as the geometry column of our data frame. Now suppose if you wish to say, as we said that it contains CRS information also for projecting on the map. Suppose if you want to know in which projection system or coordinate reference system the information or geometry is stored, right, then you can call our data frame dot CRS. So it gives us the information about coordinate system or projection system of the file, right? So it says that the data is stored in projected coordinate system of which projected coordinate system which is based on LCC WGS 84, or say this is based on the GeoGCS WGS 84 with the following parameters of datum and axis information, Cartesian information, northing and easting information, and other information about that map. So it is Lambert conic conformal with two standard parallel coordinate system. Then this is the information about datum and so on. PM is the prime meridian, right? So this way we can fetch the projection system of our shape file. Right, now suppose if you wish to rename the column, some column of your file. Right, suppose if I see the file. Right, so these are the different columns in the shape file. Like these are all non-special attributes: state, legend, shape length, shape area, and there is a column called geometry that is being designated as the geometry of our column. Now, suppose if you wish to rename this geometry, name of the geometry column, and call it, say, instead of geometry, the or state boundary actually looks more intuitive in this case. Suppose if you wish to change the name of that part, some column in our data frame, then we can call it like this: our data frame dot rename columns, then a geometry, sorry, a dictionary where we will specify the key value. So where what is the name of the column which you want to rename, and the new name like geometry dot borders, and finally we will set the geometry to be the borders column, right? So now if I see this India, now the geometry column will be not be there. Now there is a column with name borders that is designated at the geometry column. Now if I call like this India dot geometry dot name, if I call it says that the borders, right? Now suppose if I want to visualize that, so there GeoPandas offers very high level interface, as I said, to the matplotlib library. So if you directly call another data frame dot plot function, so it will just draw the all geometries available in that borders column, right? So if I call India dot plot, so now is this we can say that all the geometry. So all geometries are stored as if I see these are all polygons. So the boundaries of all states are represented as multi-polygons. So they define the different vertices of that. Like Andaman and Nicobar, if you see, it is being represented as a multi-polygon. Similarly, Andhra Pradesh is represented as a polygon. Arunachal is as polygon. Like this, all the boundaries of all states are represented maybe either as polygon or multi-polygon. And if you call just data frame dot plot function, it plots the all geometries available in our shape file or geodata frame. So then this was we were reading a .ssp file. Now suppose if your data is available in a zip file, right? So in the previous case what we had done, I might have unzipped the file and just read the shape file. Now suppose if you wish to directly read a zip file which contains different shapes, then you can directly call a zip file as well. Right. So instead of unzipping the files and giving the name of shape file, then you can directly, I think in the new pandas, latest version of pandas, you can directly call this gpd.read underscore file and you can pass it the name of zip file as well. But this zip file must contain all the shape files only, right? So now so you can just pass on the name of the zip entire zip folder as well. So you need not manually unzip then and pass the name of shapefile. You can directly pass the name of the entire shapefile. So inside this, there should be a shapefile with the name state underscore boundary dot shp. Otherwise, it may not be able to open. And so this way you can read directly a zip file as well. Right now, suppose if you wish to see the plot of this, we can see the plot and both are representing the same file. One was just zip and this. Now reading shape files from inside the zip as well. Now there may be certain cases like your zip file might contain more than one shape files, right? Like you have zipped multiple shape file inside a single zip folder. So that also, like if you wish to read. So in the previous case we were assuming that there is a single shape file inside that zip folder. Now there can be more than one shape file also inside a zipped folder, right? So in that case you need to specify the name of shape file as well while opening the file. Like here I'll be specifying administrative boundary database.zip. So this is the name of the outer folder, and inside this there is a file called majortowns.shp. Suppose if I wish to read that without unzipping the entire folder, so then this way I can specify the name of the vector file. My folder name like administrative boundary underscore database.zip, exclamatory mark, and the name of the shape file inside this folder. Then I can just pass on like name like this to my gpd.read underscore file and the name of vector file. Right. So if I plot this, so these are the different major towns. I think major towns across the different states of the India. Now if you plot this, So these are all points actually, because the density of points is too much because of these all are shown together. So this way we can see that we can read the if there is shape file, say inside a zipped folder, there are multiple shape file inside that, then you can read the individual shape file using the name of your outer zip folder, exclamatory mark, and the name of the inside shape file which you wish to read. Right, then once this is done, we can even close this. And similar way, so okay, this is already done. Reading the file from a web URL. Like suppose sometimes you have some shape file available on some web URL, right? So in using GeoPandas, suppose if you wish to read that, then in that case, you generally what we will do, we will be downloading that file from that URL to our local drive, then reading using GeoPandas. But GeoPandas provides a function directly to read from a URL as well, right? Suppose this is the URL where some GeoJSON file is available. It is in some natural earth data set. So if you pass the URL itself to your gpd dot underscore read file, then you can read that data directly from the URL as well, right? So this read underscore file method is quite versatile. Either you can pass it the name of the shape file, you can even pass entire zip folder as well. And suppose if your zip folder contains more than one shape file as well, then you can specify the name of that individual folder as well, or even you can read data directly from a given URL as well. Right now you can say this is the URL, and I am passing this URL to the gpd.read underscore file, so it must be able to read the file. Now if I see, you can say that this contains the different boundaries of different countries across the globe. So all the boundaries of the countries are being represented as polygon. Right now, suppose if I plot this you can see that these are the boundaries of all countries around the world, right? So then this way you can use GeoPandas to directly read from the URL as well. Then if you wish to see the India underscore head dot unique, anyway, this may not be important right now. This is right. So this was all about. So these we saw the different ways how can we read the file. Either we can read a single shape file, zipped folder, and the zip file containing multiple folders, or directly from a URL as well. Now suppose if your shape file is very large, like suppose if you have the data set containing the building polygons around the world, so that shape file is going to be very huge. So reading that such a huge file is quite difficult, right? So in such cases, suppose if you wish to read the subset of that data, like if I just want to read the footprint of buildings which are intersecting with, say, Dehradun city only, right? So this way pandas provide different methods for reading subsets of data as well. So there are different filters which you can use for filtering your data. So one of the basic filter is geometry filter. So the geometry filter only loads data that intersects with a given geometry, right? So we will specify the geometry, like this is the geometry, and it will just read from our shape file only the features which are intersecting with the geometry given as the read argument, right? So I'm specifying the GDF mask, so that is the mask file, and I'm reading the boundaries of state in that. Then mask.head, if you see, right? Then I have another, in one file I have the boundaries of state, and in second file I have the district boundaries. So first file I have just the boundaries of the states, and in the second file I have the district boundaries, right? File name is named district boundaries. Now suppose if I want to read from this district boundaries file only those geometry which are intersecting, like this district boundaries dot shape contains the shape of all districts across the Uttarakhand, right? Now suppose from the India's district boundary dot shapefile. Suppose if you wish to read just the boundaries of states of boundaries of the districts of the states of Assam, right? So then we can specify it like df is equal to gdf dot read underscore file and file underscore name. We are reading the entire district underscore boundary dot shp, and we are passing it a mask, right? So mask is equal to gdf underscore mask, where gdf mask dot state is equal to Assam, right? So we are passing a geometry as a filter. So gdf dot mask, so gdf mask was containing the state boundaries. So we are just fetching only the boundaries of state Assam. So like we have drawn the boundary of state of Assam, and from the district underscore boundary dot shape file, we are just picking only the polygons, or say polygons which are intersecting with the this mask, whatever mask we have specified. Mask contains the boundary of Assam, right? So we are just picking only the districts which are which are in the Assam state of India. So this way we can just read the subset of this, like, right? Like here you can say that instead of reading the entire the boundary, the boundaries of all districts of the India, we have just read the boundaries of districts of Assam state in India, right? So this way we can specify the geometric filter. We can specify using an argument called mask, right? So gdf mask dot where state is equal to Assam. Just print that, like, so this similar way we can specify a bounding box filter as well. Here we were specifying the bounding box filter as a geometrical object. Now suppose if you want to specify the filter as a bounding box, right? Suppose then we can specify our bounding box. Maybe these are the these are their longitude, min x, min y, max x, and max y, right? So this way we are specifying the bounding box. So only the geometries which are inside this, suppose if you want to filter out, right? So then while reading the file, we can specify gpd.read underscore file, name of the file, and bbox argument. So previous case it was a mask argument, we were passing the geometrical mask, and here you can specify the bounding box as well, like only pick up only the features which are in coming inside this bounding box. So we can to specify the bounding box, right? So now you can see that it has just picked up the states which are coming in that bounding box, right? It's starting from 4.9 to 5.4, right? 4.9 somewhere to 5.4, and in the y direction 4 to 4.26 somewhere, right? Like this, you can specify the bounding box as well. Only pick up only the geometries which are falling inside this bounding box. Then you can specify the row filter as well. So filter the rows loaded in the form of file using an integer for the first n rows, or a slice object, right? So suppose if you want to read only some, say, initial starting from 80 to 180 rows, just read the rows starting from 80 to 120. That also you can specify like gpd.read underscore file, name of your file, and an argument rows. So either you can specify rows, rows, or bounding box, or mask, right? So rows is equal to, we are specifying an object called slice 80 to 180. So just pick up from the entire table only rows starting from 80 to 180. Like this, you can specify the row filter as well for reading the data from our shape file, right? So this way we can see this. And field or column filter also we can specify, right? So then you can specify like just there are multiple columns inside that your filter. Now suppose if you wish to read just a single column from your file, right? So then while reading the file, you can specify another argument called column. So just read the state column only from your data frame. So gdf is equal to gpt dot read underscore file, name of your file, and columns, which particular column you want just to read. Like here I want to just read the states column. gdf dot head, if you can see that. States column got read. Then you can specify the SQL a where filter as well. Like suppose if you want to specify like a query, like the filtering as a query. Right. So here you can say GDF is equal to GPT dot read underscore file underscore name and first argument. Then you can specify where. In where you can specify your condition as an SQL where clause as well. Right. So GPT dot read underscore file name where. Then you're going to specify your query like where there is a column called state in our pandas data frame. So where is equal to state is equal to Uttarakhand, right? So it will just filter, just extract on, just read only the rows where the name of state in the column Uttarakhand is in the column state is Uttarakhand, right? So if you read, then you should read without this where clause. Right, so in our GDF, so you can say that there are so many columns and there is a column with name state. Right. So now we want to specify read only the rows where the state is equal to Uttarakhand. Like suppose if you wish to read only the data of Uttarakhand state, then we can specify it like a SQL query as well. As we said, there are multiple ways, and there is a one more way like this. Now, if I see GDF, you will see only Uttarakhand, right? All other rows have been eliminated. Only just get filtered out the rows containing the state is equal to Uttarakhand. Like this way, we can read the subset of data using multiple ways. So there are multiple ways you can choose depending on your preference. So now if I see this, you can say that I have just was able to read the multi-layer. So similar way, suppose if you wish to read the multi-layered file, so whatever actually shape file can just store a single layer. Right now, suppose there are some format like geodatabase which can store multiple layers also. Actually, it can have a layer that contains point data, and it can have a layer that contains just a line data, and it can have a other layer that contains polygons as well, right? So GeoPandas can read those formats as well. So I have this vector file name Karimnagar to underscore 2020 dot gdb. So first, before reading the file, you need to call the list underscore layer. Like suppose if you a priori know that which all layers are available in your geodatabase file, then you can just directly uh, read that list. Otherwise, suppose if you a priori don't know which all layers are available in your file, right? So for that, you can call the function gpd dot list underscore layers and pass it the vector file, the name of the vector file. So then it lists all which all layers are available in this geodatabase, right? So then if you get the layers, then while reading the file, then the function is same like LUL, say gpd dot read underscore file, the name of your file, and you can specify the layer, which particular layer you want to read from that file. Like so, if you see this, there may be a layer with the name LULC underscore poly. Like if you pass it gpd dot read underscore file and name of your vector file and the name of layer which you want to read, then it will be reading that particular layer only from your geo package, right? So similar way, you can read a GeoJSON file also. In this, I have a GeoJSON file called almora.geojson. I will open that file. This is a GeoJSON file. Actually, I think it is. So like this, as we said that, so this is the description of that file. Like type this file contains all feature collection. Then these are the features inside that feature collection. Their type is feature property. These are their properties, and this is the geometry of that first feature, second feature, and so on. Now let us try to read this file using GeoPandas, right? So the function is same gpd dot read underscore file and pass it the name of GeoJSON file. Now if I see this Uttarakhand, then if when I can plot this, There was some problem with, I think there is some problem with the file. Because of that, it is not able to plot. Otherwise, it would have plotted it like this one, right? So similarly, suppose if you want to subset anyway, while after reading also you can subset your files, right? As we have done in case of pandas, like, or while reading itself you can subset, or even also after reading as well you can subset, as we have done in the pandas, right? Now if I see gdf.head, so this file contains the all major towns across the different states of the India, right? Now suppose if you want to, from this you want to just extract the major towns of, say, a state Tamil Nadu only, right? You suppose you are interested in studying just Tamil Nadu, then you can specify it like this: subset is equal to India, then your data frame name, then inside your square brackets your data frame, and this which column you are referring to, state is equal to Tamil Nadu. So it will just fetch all the towns, because the towns are being getting represented as, say, point features, right? So it will just fetch only filter only the rows which contain the state name as an argument, state name as Tamil Nadu, right? Now if I plot this, so these are all different cities, major towns of the Tamil Nadu state, right? So plus, suppose if you wish to explore these different point features on, say, an interactive map, right? So then there is a function available called explore, right? Then you can just call your data frame dot explore, and on which attribute you want to explore. Say suppose if you want to explore it on the name, say, district, want to attach. So if I say call subset dot explore on the district and legend is equal to false, then you can say that a nice interactive map has been created, and these all points have been collected in that, and the color of these points have been assigned based on the name of their district. Like, so these all yellow points are to a district. Like if you click on this, it says rotation scale, name of town, this is Kamanya ka Palian, and these are in district Coimbatore. Like these all green, maybe to another district, Dharampuri. So these are clubbed together or colored based on the name of district. Like, so you can call this function as well your data frame dot explore, and you can specify the name of attribute column on which to color, give the color to these geometries, and legend, if you wish to attach legend is equal to false, then you say get an interactive folium map on that, which you can quite easily see details about all these things. So this previous map was a static map. So similarly, suppose if you wish to uh, see them on an interactive map, you can call the explore method, right? So then finally, once it is done, you can call the close method. Then thank you. Right, so with this, we come to the end of today's session. So today we discussed about vector data. As we said that vector, so all the features on the Earth's surface can be represented as, say, raster or vector data. So vector data is useful when we have to represent discrete data. So discrete data means when there are clear, distinct boundaries between different objects. So in that case, that can be represented using vector data. When the data is of the continuous form, then we can represent it using a raster. When we have discrete boundaries of among the data, then we can represent it using vector data. So the vector data can be represented as, say, using point, line, and polygon. Then we discussed about geo pandas. So two primary data structure in pandas, that is data frame and geo series. So the extension of pandas is geo pandas, that is geo data frame and geo series. So geo series contains the all geometries of our vector data, right? So all mathematical, all or geometrical operation which we can apply on the geometries, we can apply on the geo series. So then we see how do we read different vector formats, starting from the ESRI save file to GeoJSON to geo database and all. Then we saw how do we subset, or while reading itself, or maybe after reading as well. And then we discuss about a function called explore, available in geo data frame, where we can explore all our features in an interactive data frame. So thank you very much for attending this session. If you have any questions, please post them on the chat box. We will try to answer with best of our knowledge. Right. So we'll be back after 5 minutes. So thank you very much. So welcome back. Now I will take a few questions. So Sandeep has asked, how is raster data useful when we can always use geo-tagged arrays, raster data to represent roads, rivers, etc. Is it about smaller size? How I think you wanted to use how vector data is useful, I think, right? So actually, as I said, that vector data is useful because of when we have clear distinct boundaries, right? So when we have clear distinct boundaries of boundaries in our data, like we can clearly distinct one clearly separate one object from another object in our data. So in that case, raster is not very good for such features, right, where we have clear distinct boundaries. So in that case, vector is quite useful in such cases, like suppose if we wish to represent the boundaries of states, right? So raster is useful for continuous data. So the boundaries of the state or say any feature will be distinctly distinct from one another, right? So in these cases, vector representation is more useful compared to raster, because raster we cannot represent the boundaries clearly. So in those cases, vector is more useful. So about this notebooks and quizzes, actually, most probably I think today we'll be uploading all the quizzes, all these notebooks, which whatever we have till today. So all these will be uploaded mostly by today. So don't worry. So how can we use GeoPandas to perform spatial joins between two geospatial data sets? So in the subsequent lecture, we will talk about this performing the spatial joins on spatial geometries in the subsequent lecture. Today, actually, I have just introduced you how do we read these geometrical data sets. So in the subsequent lecture, we will see how do we do these spatial joins on different different geometries. So what is the ESRI meaning? Also, ESRI is the name of a company. So exactly full form I don't remember exactly. So ISRI is the name of a company. So they have the proprietary format of shape file, so that we can use. So what is the easting and northing of location? So easting and northing are used when we are using a projected coordinate system, right? So these false easting and false northing are some offsets that we are adding to the coordinates of the point, so that we don't get negative numbers, right? So these is false easting and false northing are the offset which are adding to the location of a point, so that we don't get the negative points for these point. For not for getting for converting the negatives to positive integers, we are adding these easting and northing in projected coordinate system. So are there any other filters used apart from this? So I am not sure about are there any more filters for subsetting the vector data? Actually, you may go through the GeoPandas document. If something is available, you can just check from there. So can the execute advanced geospatial functions such as distance, area, and like? So in the subsequent lecture, we will talk about all these operations on the all different geometric operations which we can apply on the geometries of our all operations we can apply on the geometries. We will discuss in the subsequent lecture, like how do we calculate the length or distance between the points, calculate the area of a polygon, and so on. So so these all operations we will discuss in the subsequent lecture, right? So I think there are no more questions. So I hope I could answer all the questions. So with that, we are signing off. So see you tomorrow. So thank you very much.